CERN's experimental search. Armed with the world's most sensitive particle detectors, CERN scientists began their systematic hunt for evidence of microscopic black hole creation. The CMS experiment at CERN has conducted extensive searches for microscopic black hole signatures in high-energy proton-proton collisions. Using data collected during the LHC's operations at 7TeV center of mass energy, researchers analyzed collision events looking for the distinctive particle sprays that would result from black hole evaporation. According to CERN's published results, if microscopic black holes were produced, they would evaporate almost instantaneously through Hawking radiation, creating characteristic patterns of subatomic particles detectable by the CMS detector surrounding the collision point. The search methodology involved examining invariant mass spectra of particle jets, looking for anomalies that couldn't be explained by standard particle physics. Scientists used sophisticated Monte Carlo simulations to model expected black hole signatures, comparing these predictions against actual collision data. The ATLAS experiment has also conducted similar searches, analyzing electron plus jet and muon plus jet invariant mass spectra with 140 inverse femtobarns of collected data. These experiments represent some of the most sensitive searches ever conducted for quantum gravitational effects, pushing the boundaries of what's experimentally accessible in fundamental physics.